Okay, so we're getting towards the first part of our idea about how to make our perfume, how to make our smell. But to do that, we have to talk about what a chemical reaction is and what esters are. So before we get started, I want you to go ahead and do the functional group refresher on our Echo. It's a Google form. Pardon me. And I'm setting it up so that you can see whether your answers are right or not. But the idea of this is that we kind of get another look at what a functional group is in an organic molecule, because it's those functional groups that are unique and important. So go ahead and do that for a little bit. Okay, so when we talk about smells, when we talk about compounds, we have to ask ourselves, what is a chemical reaction? Okay. And basically, a chemical reaction is when the actual elements get rearranged to form some sort of new molecule. So a chemical reaction is basically you take the atoms and you rearrange them to form something new. You break some bonds and you make some bonds. That's a chemical reaction. Now, we do actually have something called a chemical equation that shows what happens during a chemical reaction. What you start with are called the reactants, and what comes out, or what you end with, are called the products. Okay, so here is an example of a chemical reaction. We have butyric acid, and we know this is an acid because it contains that little functional group right there. And we combine it with an alcohol, which we know this is an alcohol because it has the little functional group right there. And when we chemically combine these, we get an ester, which we know this is an ester because it has the carbon, oxygen, carbon double bonded oxygen to the carbon. So this is an example of a chemical reaction where the reactants start out and the molecules look one way, but then during the chemical reaction, we make and break bonds so that we form a new arrangement. Now, this is not an isomer. This is a totally new compound. Now, if we go back and take a look at the acid, the butyric acid, remember that organic acids tend to smell a little putrid, they tend to smell a little sour, but if we're going to make an ester which smells like fruit or smells sweet, we need that putrid component mixed with an alcohol component. Because what we're doing is we're actually breaking the bonds in the acid and in the alcohol, and we're forming a new compound, a new ester. Now, of course, you'll also see that one of the byproducts is water. So that's another product. And the reason that it makes water is because of the law of conservation of matter. Now, the law of conservation of matter states that matter cannot be created or destroyed. So however many elements or however many atoms you start with, that is the number of atoms you end with, that is the amount you end with. Okay? So however much all your ingredients weigh, that's how much your cake would weigh, if that makes sense. So if we were to take another look at the reactant, you'll notice that the number of carbon atoms on the reactant side is the same as the number of carbon atoms on the product side. Okay? There's 6 carbons between butyric acid and ethanol. Like if we consider the whole reactant side, it has 1, 2, 3, 4, 5, 6 carbons. And there's 1, 2, 3, 4, 5, 6 carbons on the product side. That's because those elements are not spontaneously created or destroyed. They're just rearranged. And that's what the law of conservation of matter tells us, is that the compounds are rearranged, or the elements are rearranged. They're not suddenly created or destroyed. Now, we show this with a chemical equation that looks something like this. And we can count the number of atoms for each element on both sides of that arrow. Now, everything that happens before the arrow, those are the reactants, those are the ingredients, and then they point to the products which is what we make in the reaction. And you'll notice that if we were to add up the number of carbons, we have 4 carbons in this compound, we have 2 carbons in this compound, which add up to a total of 6, meaning I'm starting with 6 carbons in my ingredients. Then over here you can see that I have 6 carbons in my product. So no carbon atom has disappeared. Every carbon atom has a place and is used up. Now, this kind of brings us to the idea of, okay, what's really going on in this structural reaction? Okay, so because this is just a side note, this is showing structural formulas, whereas this is showing chemical molecular formulas. So there is a difference there. So when we look at the structural formula, okay, we have that carboxylic acid. In this case, this is our butyric acid, and then we have an alcohol. So remember that R stands for anything. It's random. It could be an H, it could be another C. It doesn't matter. But we have an alcohol and an acid, and what happens during this reaction is the OH from the acid connects with the H from the alcohol, and that's where we get our water. And that once we take that out, this process is called condensation, by the way. Once we take that out, we're left with our ester. It's got the acid fragment and it's got the alcohol fragment. Okay, so the 2 ingredients of an ester are a carboxylic acid and an alcohol. Now, in order for that to happen, you may have noticed that there are these things on top of the arrow. These are ingredients that aren't really used, but they're necessary for the reaction to happen. For example, a pan or an oven, an oven. An oven only speeds up the baking process. The higher you put the temperature, the faster the cake will bake. Okay? That's what this little triangle means, is temperature. If we heat this reaction up, it'll happen faster. This little hydrogen right here, this hydride ion, says that we need extra hydrogens. Now those 2 things, or the hydrogen, is called a catalyst. Now a catalyst is something that makes a reaction happen more quickly. Now what I've got on the screen here is an image of something called a catalytic converter, and a catalytic converter is a catalyst for your car. What it does is it turns the more noxious fumes from your exhaust into safer, less noxious fumes. Okay, so I'm not going to say it makes them safer. It just makes them less noxious and makes them less dangerous for the environment. So catalysts are something that speed up the chemical reaction the same way a catalytic converter speeds up the natural decomposition of the gases from your car. Okay, so just to refresh, I want you to really take away that the functional groups are the unique portion of the molecule that is responsible for its reactivity, that it's responsible for the way that it reacts with other compounds, with other functional groups. Okay, because we're going to be making esters, meaning we want to make things that smell sweet, but we're going to start with things that smell putrid. So it's important to really understand that in this chemical rearrangement, it's the functional group that has that plays the most important role. Okay, now your assignment is, these are some of the terms we've talked about so far in our lessons. And what I want you to do is I want you to create a concept map in Google Drawings. Or I found out today some of you are familiar with the concept map program called Inspire, which you're more than welcome to use that if you'd like, or you can use Google Drawings. But you're going to choose 10 of these terms, and you're going to create a concept map showing how they're connected. Now, I have an example of a concept map. If we click on this link, and And I'll actually connect a video on like how to make a concept map too. Because what I want you to do is to create a concept map using 10 of these terms. You'll notice there's more than 10, so you have to pick the 10 that you think are most important. And then you have to show me how those words are related to one another. Okay? So hopefully this video helps clarify some things about chemical reactions and helps us kind of get a view of why we're talking about chemical reactions and how this relates to our perfume. So if you need anything, please feel free to shoot me an email.